Now, when we're in class and we're going over this extraneous solution idea, I always like to show this as my second example. And it's because it looks so similar to the first that a lot of people tend to work it the exact same way and they tend to get the same answers. And the weird thing is that you are not going to get the same answers for this question as the first one. And I'm not sure how that happens. So let's walk through the solution steps. The solution steps are going to look identical. The only difference is the solution itself is going to be different. So again, just be kind of careful about this. I've seen a few people do this on the homeworks where you see something very similar to the question that we've already done in a lecture pops up on the homework, and you just pop in the same answer. And so let's see that there are some slight differences here. So my example 2, I get sine of x plus 1 is equal to cosine of x. So I'm going to do the same thing I did before, and I'm going to square both sides. Now remember, the fact that I need to square both sides is going to give me possible extraneous solutions. It doesn't mean that there will be extraneous solutions, it just means that there is the possibility of them. So in this case, I'm getting sine squared of x plus 2 sine plus 1 on my left-hand side and cosine squared on my right. Since the majority of my stuff is going to be in sine, I'm going to convert my cosine. So this gives me 1 minus sine squared x on the right-hand side. Just like before, I'm going to move my right-hand side over using my rules of algebra, and it's going to give me 2 sine squared of x plus 2 sine of x is equal to 0, giving me that thing that I can do with the zero product property once I've factored out that greatest common factor. Now in this case, I get x is equal to pi, x is equal to 0, and x is equal to 3 pi over 2. So you notice that our solution set also, for our basic solution set, is going to look a little bit different than it did in our first example. But again, when we do this in class, I'm kind of astonished to see how many people still get the same answer as we did for the first example, even though at this point you can see that these are very different. So just like before, we're going to check our basic solutions. So I'm going to plug in pi for the x in my original equation. I'm going to plug in 0 for the x in my original equation and 3 pi over 2. I'm going to find that pi doesn't work because it gives me 1 is equal to negative 1, so this is not part of the solution set, but that 0 and 3 pi over 2 are both parts of my solution set. So again, be careful here, these are just our basic solutions. You still need to write these in the generalized form just like we did before. So don't forget that, if this is going to be tangent or cotangent, we still need to worry about this being a multiple of pi instead of multiple of 2 pi, which it would be in this case because sine and cosine are both multiples of 2 pi.